In this video lecture, we're going to start talking about the basic code structure of methods in Java. Okay, let's get started. For starters, recall that we said a method is one of the three types of containers in Java. A method is a container for executable instructions or statements. All the statements within a method appear inside a block, this body of code between a pair of curly braces. If we break any method down far enough, we can see that it's comprised of two main parts: the method interface, which appears before the curly brace pair, and the method implementation, which appears inside the curly brace pair. This diagram on the top right shows the general layout of a method as code. But we can also think of a method in terms of a black box model. Here on the bottom right, we can see that a method's interface is simply its boundaries to the outside world, its inputs on the left and its outputs on the right. Taken together, these two sides comprise the method's interface, and again, everything inside the box, just like inside the curly braces, comprises the method's implementation. We'll soon see there's a very direct mapping between this type of modeling generalization on the bottom and its actual code realization on the top. For starters, let's first examine the method interface. In this slide, we can see the general form and a couple examples of a method interface. This is a useful summary reference, so you may want to keep this handy while you write your first few methods. The first item which appears in a method interface is its access specifier, shown here in black. The access specifier specifies the visibility of a particular method to outside programs. Can they or can they not see and use this method? For us, this will be one of two values, public or private, although there is another protected access specifier, but we won't be using it in this course. By the way, all three of these values are also Java keywords. For now, we'll also add a static access specifier if our methods are alongside and called directly from main. This is only temporary, and we'll talk about this a bit more later on. The second item which appears in a method interface is the return type, shown here in green. The return type indicates the data type of the value that is output from the method. A return type can be of any primitive data type, any class type, or else void if no value is output from the method. Notice that if a method does have a return value, a variable of that type is returned as the last line of the method, and it must be on the last line. Otherwise, if a method returns no value, the return statement is optional. The third item appearing in a method interface is the name of the method itself, shown here in blue. This name is a Java identifier, so it must follow all the usual naming rules and should use camel case naming. Method names represent actions, so method names should clearly indicate what the method does. The last item which appears in a method interface is the argument list, shown here in red. The argument list is a comma-separated list of data type and variable name pairs, and these represent the inputs to the method. If the method takes no inputs, then the argument list can be left blank. Having said all this, let's look at these two examples. In example 1, the method name is addTwoNumbers, which is pretty self-explanatory. It takes two integer numbers as input and returns a result as an integer value. This method is public, which means that the outside world can see and use this method. In example 2, the method name is displayMessage, so this method accepts some input message text as a string input, presumably prints that message, but returns no value, as shown by this void return type. This method is also public, so the outside world can see and use this method as well. So, now you've seen all the specific details of a method interface. This next slide is the key to implementing a method, given some conceptual problem description. You'll definitely want to refer back to this when you are writing your first few methods. Let's imagine that we can describe some problem with a black box model as shown here. We know some inputs, here on the left. We take some actions upon those inputs, and we compute some result, here on the right. If we can conceptualize a problem in this way, it's very straightforward to turn that description into a Java method. The key thing to note is that we have a crossing pattern of sorts going on here. The output side of this model translates to the left side of this method interface. The input side translates to the input arguments within parentheses, and the name on the black box simply becomes the method name. Within the method, all these quantities in green correspond to the output, or the unknown, or what we are computing. In order to compute that output, we simply make use of these quantities in red, which are our inputs, or our knowns. If you refer back to this diagram when writing your first few methods, I think you'll find methods to be a little more straightforward. In software development, we often refer to the input-output boundaries of some method, or the first line of a method in code, as its interface. An interface is sort of like a software contract. It's something we can count on or rely upon. Some outside client user of our method, who might not know anything about its internal details, can use our method in their program by relying upon that interface. An interface promises some outside user, if you give me these certain things, I will in turn give you this. By necessity then, an interface description is very specific. It is very explicit about the number, order, and data types of each of its inputs. But it couldn't care less about the actual variable names a client uses when trying to use that method. As a real-world example, think about a standard 3-prong electrical wall outlet. That's an electrical interface. We generally don't care much about how the upstream electrical power has been generated. Hydroelectric, coal, nuclear, solar, we don't really know or care. As long as our device's electrical plug will fit into that wall outlet interface, we can be assured of getting reliable 120-volt electrical power. Or think about a USB port. As long as our device's USB jack fits into that port, we have a reliable data and power connection for computer applications. Recognize that all method names are Java identifiers, which means they are names we get to specify. As such, they must follow all of the typical rules for Java identifiers, and they should observe all of the good Java naming conventions, such as beginning with lowercase letters and using camel case naming. Beyond that, methods are intended to describe software actions, so we should name our methods with good verb-centric names. Here are a bunch of examples of good method names. Notice that each of these method names begins with some kind of verb, even set first name and get first name. Also, do you notice that each of these method names contains a trailing set of parentheses? This is a frequent convention you'll see and that we'll use in this class to indicate that something is a method. Finally, remember that a method is nothing more than a container for Java statements. Inside the curly braces statement block, all contained statements will be executed sequentially. The method can also use any input arguments as additional available variables, and those variables do not need to be redeclared because their presence within the method interface inputs serves as their declaration. We can also declare additional local variables within the method. We can create and use new objects, and we can call other methods in a nested fashion. In short, anything we can do in Java, we can also do inside any Java method.